right, we're going to talk about similar polygons. So there are a couple of requirements. In order for shapes to be similar, the corresponding angles have to be congruent and the corresponding sides have to be proportional. So here's what that looks like. So here's an example of similar polygons. The first thing, their angles are congruent. Well, they're both rectangles, and rectangles have to have 90-degree angles. So you know all the angles are going to be the same. And corresponding sides are proportional. What that means is if I set up my heights as fractions, so like 3/6, it should be equivalent to the bases as fractions, 1/2. 3/6 does simplify down to 1/2. So you know that we do have proportional sides. So these are similar. So one of the key terms that we have to talk about when we talk about similarity is scale factor. And the technical definition is the ratio of corresponding side lengths. But the really easy definition is it's just how many times bigger or smaller your shape gets. So right here I have two triangles. This is my original shape, and then I drew an arrow to show you I made it bigger by multiplying it times a scale factor. But we need to figure out how many times bigger I made it. So what we're going to do is we're going to build a fraction, and we're going to say it's new over old. That just means we're going to take one of the new side lengths and put it on top, and the corresponding old side length is going to go on bottom. So I could do 6 on top. The corresponding side length would be 2. 6/2 simplifies to 3. 3 would be my scale factor. You could also say, so I'm going to label it, that's my scale factor, SF. You could also say that this triangle became 3 times bigger. All right, we use scale factor and the rules of similarity a lot when we have shapes and we have to find the missing side. So I have two rectangles here. They are similar. I'm going to go ahead and just tell you that. So what we're going to do is we need to find x, and we're going to build proportions in order to find it. So the first one I'm going to do is I'm going to take the corresponding sides. So I'm going to put 5 over. The corresponding side on the other shape is 7, and that equals 6 over x. At this point, you could just cross multiply and divide. When you do that, you get that x equals 8.4. There is another way to set up a proportion. This one I did small shape over big shape. I could also build a fraction out of the two dimensions from the same shape. So I could say height of the small shape over base of the small shape equals height of the big over the base. If you see, when you multiply and divide, you would get the same exact answer. So it doesn't really matter how you build your proportions as long as you're consistent. If your first fraction is small height to big height, then your second fraction also has to be a small dimension over a big dimension. If your first rectangle, sorry, I had someone come in, so I'm not sure where I stopped, but on this proportion, we did the height of the small over the base of the small, and you just have to say consistent and do the height of the big over the base of the big. Either way, you'll get the same missing side length.